Set. All right, we're looking at 7.5.5, Simplify Algebraic Expressions, page 387. Make sure that you title your page appropriately. So we're going to go on to the definition here where it says identify parts of an expression. And I think that this diagram here really sums it all up. It says that when you add or subtract signs, separate an algebraic expression into parts. Each part is called a term. So between subtraction and addition signs, you have terms. So recall that the numerical factor of a term that contains a variable is called the coefficient. So this will be another note. We'll write this in just a moment. But if we had, for instance, this negative 4x, the negative 4 is called the coefficient, and the x is called the variable. So that's just a little review of vocabulary that we've done before. Like terms contain the same variables to the same powers. So for example, if you had 3x squared and negative 7x squared, because it's x squared and x squared, you can combine the like terms. But if you had x squared and x, those are not like terms. Okay? So those are not like terms. So they also say so are 8 times x times y to the second power and 12 times x times y to the second power, because we're still talking about the same variable sequences. But then they say, well, if it was x squared times z and then x times z squared, those obviously aren't the same variables, so they cannot be combined. So it says that the term without a variable is called a constant, just a whole number. Okay, so, or well, I can't always say a whole number, but a constant is just a number by itself without a variable attached. So coefficient has the variable attached. Constants are just the number by itself. Okay, so for this example, the only constant they have is the 12, but they do have two like terms where they have x and x. So they have negative 4x and they have positive x, and you can combine those. And we'll talk about that in just a second. So it's asking you what over here in the stop and reflect, circle the term that is a like term with negative 4x to the third power. The only thing that goes with that is is x to the third power, because x to the second power and negative 4 doesn't even have a variable anywhere. Alright, so example 1, we'll go over some examples. It'll start clicking a little bit better, okay, because that was kind of just a lot of vocabulary thrown back at you. So number 1 says identify the terms, like terms, coefficients, and constants in the expression. So we're going to write the expression. The first thing I want you to do is write 6n minus 7n minus 4 plus n. And it says it wants us to identify the terms. So each of the terms are separated by the subtraction signs or addition signs. So these each are the terms. So they show it right here. Terms are, so I want you to write this, terms, and then the colon, and then 6n, comma, negative 7n, comma, negative 4, comma, n. The like terms, and the reason that we can say negative 7n and negative 4, since we can change that to a plus a negative, it means the same thing as minus. Plus a negative is the same thing as adding its opposite, right? Don't forget, adding its opposite. So negative 7n can become adding its opposite, or minus 7n becomes adding its opposite. Okay, so those are our 4 terms. Then it wants us to do our like terms. Well, for our like terms, we have our n values, which are 6n, 7n, and 1n, because we know that n by itself is 1n. We don't have any like terms to go with our negative 4, which is our constant. We don't have anything to go with that. Now it wants us to list our coefficients. So the coefficients, remember, are the numbers that go with the variable. So we've got the 6 here, the negative 7 here, and in this case, the invisible 1 here. So you notice that the 1 is listed, even though it doesn't show the 1. We know that n by itself means 1n, 1 times n. So that's a coefficient, it's just invisible. And we need to add it in there, make it not invisible anymore. And then the constants are just the negative 4. That's the only constant that there is. So now we're just going to, again, identify the like terms, the coefficients, and constants in each expression. So for A, I'm just going to write out my parts here, and you'll want to do that as well. Pause the video if you need to. Alright, and if you put them side by side like I have here, you can just keep using that this is going to be the line for terms, this will be the line for like terms, this will be the line for coefficients, and then I don't have to rewrite these words over and over again. So, the first thing that you should do is look for terms, then the like terms and coefficients and constants. Go ahead and pause the video so that you can do these on your own. Alright, we'll start first with the terms for each one, and then I'll go through each one separately. So the terms, of course, are just each of the sections separated by a plus or minus sign. So we have our 9y's, we have our plus and negative 4, so we're going to say negative 4 is another one, negative 11y, and then positive 7. And then for the next one we've got 3x, 2, negative 10, and negative 3x. So those are the terms for both A and B. As far as like terms go, for A, for like terms, we have our 9y and our negative 11y, and we also have our negative 4 and our 7. Those are in two different sets of like terms. And then over here we have our 3x and our negative 3x, as well separately we have our positive 2 and our negative 10. As far as coefficients go, for coefficients we are talking about just the numbers before the variable. So we have a positive 9 and a negative 11. Remember that minus sign goes with the 11. And for B we have the 3 that goes with the x, and then we have the negative 3 which goes with the other x. Alright, then for constants we're just looking for those numbers that have nothing else going with them. Negative 4 does not have a variable, and positive 7 does not have a variable. And then for example B, the positive 2 and the negative 10 each do not have variables. Those are called constants. So coefficients with the variable, constants with no variable. And you can combine like terms that have the same variable with it. Or if they're both constants, you can combine those because those are also called like terms. So simplifying algebraic expressions, and we've done this before, we're looking to simplify them until they don't have any more like terms. So sometimes we need to use distributive property to combine like terms if necessary. And we'll go over some examples like that. So we're trying to get to simplest form. You're not solving it, okay, because we're not going to know what the variables are. We don't know what the values of those variables are. But we are going to be able to simplify it as low as we can where there's no other like terms. So example number 2 says write 4y plus y. So I have 4 yo-yos plus 1 yo-yo, right? And so they say let's use distributive property, and let's take the 4 and the 1 and factor out the y, and we've got 5 in parentheses times y. But I think that if you just think of it as 4 yo-yos plus 1 yo-yo, it's 5 yo-yos. It's the same situation. They just want to make sure that you understand why that works, because distributive property says that y times 4 plus 1 is the same as 4y plus 1y. So we can combine the 4 and the 1 and make 5 right off the bat. Alright, so the next one says 4x's minus 2 minus 7x's plus 6. And I like to say it like that, where I say the x's, because it makes me think, oh, okay, those are the same thing. I'm saying the same thing. 7x's, negative 2, or minus 2, minus 7x's, plus 6. And you can say negative 2 ones if you want to, if that helps you figure out the difference. So when we've got like terms that we want to simplify, we're going to, you can use different colors if you want to, or use different shapes if you want to write out the original expression. So we've got 7x's minus 7x's. Well, what's 7x's? Take away 7x's. Hopefully you figure out that that's nothing left over, right? 7 xylophones minus 7 xylophones is 0 xylophones, and that's just 0, that's nothing. But then we've got our negative 2 plus our 6, different signs subtract. We're going to do, it's going to be positive 4 because we do 6 minus 2, which is positive 4. Alright, and so ultimately we end up with just 4 because we simplified it all the way down that we got rid of the 7x's. That's not always going to happen, but don't be afraid when it does. It's okay if the variable completely disappears if that's what the expression makes us do. So it says equivalent expressions over here, a little note. To check whether 4y plus y and 5y are equivalent expressions, you can substitute any value for y and see whether or not it works. So you could say, okay, what if we said y equals 2? Then we could say, okay, 4y plus y would be 4 times 2 plus 2, that's 10. Is that the same as 5y? Well, if y is 2, 5 times 2 is 10, so yes, it works. It is equivalent, because when we simplify an expression, it should still be equal to the original expression. We're just simplifying them. So here we go. We've got 4z's minus 1z. And remember that when we don't have the coefficient there, you can write in that invisible 1. I almost always do. It just helps me remember. So you've got 4z's minus 1z. What do you end up getting? 3z's. All right, so you do D and E on your own, and when you come back, we'll go over the answers. Pause the video now. All right, so here's the answer. For D, the minus 3n's plus 3n's actually cancel each other out, because 3n's plus 3n, or negative 3 plus positive 3 is going to make 0, and 0 times n is 0. So we are just left with that constant of 6. For E, we've got our g's we're going to put together. We have 2 g's, take away 8 g's. So you owe 6 g's, basically, right? Think of that. Is that money? All right. And then negative 3 plus 11, you subtract, take the sign of the higher number, absolute value. So that's going to be positive 8. So negative 6g plus 8. So 2 girls take away 8 girls means you're negative 6 girls. And then negative 3 plus 11 makes 8. So example number 4, the cost of a jacket, J, after a 5% markup can be represented by the expression J plus 0.05 times J. Simplify the expression and then determine the total cost of the jacket after the markup if the original price is $35. All right, so here's the thing, and I hope that you catch on to what we already have done before. But if they're telling us the cost of the jacket and we're going to have to mark it up by 5%, that means we're increasing it by 5%. We're not discounting it, we're marking it up. So that means that the final price ends up being more expensive. So that means that we're going to do the 100% plus 5% to be multiplying times 105%. So I just want you to remember that's what we did before. When we did discounts, we subtracted the percents from 100, but when we're doing markup, we add it to 100. When we do sales tax, we add it to 100. So now let's look at what they did. They did, okay, the cost of the jacket plus the cost of the jacket times 0.05, which is 5%. When we put the little secret invisible 1 in front of the J, we have 1 J's plus 0.05 J's, and so that's 1.05 J's because we add together those coefficients. And isn't that 105% times the cost like we talked about before? This is just like a review. So 1.05 times J. Then they tell you later, because they wanted you to do this, then they tell you later that you're going to say that the cost of the jacket is $35, so it's going to be 105% of $35, which is 1.05 times 35, $36.75. It makes sense that when they mark up the price, that it's more than the original cost. So it should be $36.75 because it's more expensive than it was that they purchased it for. All right, you're doing F on your own where it says write an expression in simplest form for the cost of the jacket. So you're going to use the jacket from the J, the jacket from example 4, but now the markup is 8% instead of 5. So you need to figure out what the expression is, and then you need to figure out what the total cost is after markup. So that's what they had done here. They had figured out what the expression was, and then they figured out what the cost was. So you can use the same process that you used for example 4 to solve for F. So go ahead and solve F, and we'll come back and go over the answer. Pause the video now. All right, so the expression would be 1.08 times J, because again it's a markup, so I'm increasing it the 100% of the cost plus 8% of the cost, so it's 108%, which is written as 1.08. And then it's going to be times the original cost of the jacket. The original cost of the jacket was $35, so I'm going to do 1.08 times 35, and it ends up being $37.80. Make sure you don't give it to me as 37.8, because that is not how we write money. So we need to write it as $37.80. Example number 5 says, at a concert you buy some t-shirts for $12 each and the same number of CDs for $7.50 each. Write an expression in simplest form that represents the total amount spent. So it says, let X represent the number of t-shirts and the number of CDs. Oh, because it says that you got the same amount. This is the key word, that you got the same amount. Otherwise, our variable could not be the same number. It couldn't be the same letter. But since it's saying that we bought the same number of CDs and the same number of t-shirts, X can be the same. So 12 times X represents the $12 for each t-shirt, X number of t-shirts, plus $7.50 times X to represent $7.50 for every CD times X amount of CDs. Because again, this is going to be the same amount of CDs. So the expression that we would simplify it to would say, all right, depending on however much the number of items is that we bought, it's going to be $19.50 times X. Because it's going to be the $12 plus the $7.50, $19.50 times X. It's kind of like if you're going to the movies, and that might be the next example. No. When you're going to the movies and you've got 5 people with you and you're all buying this ticket for the same price and you're going to each of you buy a drink and you're each going to buy a popcorn, it's the same number. So if you add up the cost of the ticket, the cost of the popcorn, and the cost of the drink, and then multiply it by how many of you there are, that figures out what your total cost would be. All right, if you got that. All right, G. You have some money. Your friend has $50 less than you. Write an expression in simplest form that represents the total amount of money you and your friend have. So think about that. See if you can figure out that expression. You're not going to be able to solve it. Just figure out what the expression would be. Pause the video. All right, this one's a little tricky to figure out unless you write it out step by step. So if I said X represents the amount of money that I have, and I'm going to add my money and my friend's money together, but my friend has $50 less than me, I would be taking my money, which is X, minus $50. So it's basically like, here's me, and here's my friend's money, and I'm adding them together. So me, I'm X, my friend is X minus 50, and so if I simplify the expression, then I'm going to have 2X minus 50. So 2 times my money, then take away $50. I don't know, that makes sense to me. Does that make sense to you? No. Yeah, well, good for you. All right, okay, how about this? So I'm saying that I have $100 and you have $50 less than me.
Wait, are you videoing this?
Yes.
Oh.
So I have $100 and you have $50 less than me, and I want to know the total between me and you. So I have 100, and then you have $50 less than me. So I have 100 plus you have 100 minus 50. But isn't that the same as saying 2 times my money, take away $50?
Yeah. Yes.
Because we're talking about combining our money. So it doesn't matter that I have 100 and you have 50. It matters that it's 200 minus $50 is how much we have together. Okay, so it's like 2 times the 100, take away 50, and it end up being the same idea. Okay, all right. So I know that's complicated when it's kind of a vague number. All right, so that is the end of our video. I hope you guys enjoyed this amazing thing. I don't know what that means.
It was so
Goodbye, guys.
You nuts?